Okay, so we're going to start off chapter 1 by looking at just reviewing elements on the periodic table, the different groups that exist, and different properties of element types. So here we have our general periodic table, right? So here we have our different groups and our different periods. So just to recap, a group is a vertical column. So in total there are 18 columns or 18 groups. And a period is a horizontal row. So here we have period number 1, period number 2, period number 3, etc. down to 7. So even though these may look like they are different periods, they actually are a part of periods 6 and 7. You'll notice here, it jumps from 57 to 72. So those elements that are missing are actually right here. So just keep that in mind, right? There are only 7 periods on the periodic table. So we're going to go over the different groups. Of course, there's different colors. This is a nice colored version. There are many online that you can take a look at. And of course, you have your periodic table from your reference charts. Okay, so group number 1 we're going to look at, and they're known as the alkaline metals. So all of this is going to be familiar. You've done this in grade 10 and of course in grade 9 as well. So alkaline metal is in group number 1. And notice we do not include hydrogen when we're talking about this first column. So remember, a chemical family or a chemical group are things that are essentially elements that have similar properties. So all of the elements that are in group number 1 have similar properties, of course, other than hydrogen. It's kind of like the odd one out. So alkaline metals, of course, are all metal elements, and they all have one valence electron. So just quickly, we will review. So a valence electron, so when we look at a Bohr Rutherford, let's look at lithium, for example. So lithium has 3 protons, and we had, I covered it up, but it has, 7 minus 3, so it has 4 neutrons. So remember, neutrons, you take your atomic mass, you subtract your atomic number, and we start drawing our orbits. So the first energy level, or the first orbit, has a maximum of 2 electrons. Ooh, the dot doesn't want to go there. And then, of course, because there are 3 electrons, we would have to add another shell, or another energy level. So the valence electrons are the electrons that are found on the outermost energy level, or think of it as the last orbit that you draw when you're looking at a Bohr Rutherford diagram. So all of these elements have 1 electron that is on that last shell. So this is actually very unique in that they are very reactive because of this. So actually, you never find alkaline metals in its pure form in nature, because anytime an alkaline metal comes in contact with other elements, it tends to react. The reason why is because it has only 1 electron on its outer shell, so it's very easy to lose that electron to become an ionic compound. We will review all of that later on in this unit. So, of course, what I want you to know is that alkaline metals are the most reactive metal group. And actually, as you go down the periodic table group, the elements become more and more reactive. So potassium is more reactive in comparison to sodium and lithium, but rubidium would be more reactive than potassium. So as you go down, it's more and more reactive. Okay, so the second group on the periodic table is also a metallic group, and they're called the alkaline earth metal group. So every element that is in this group has 2 electrons on its outside orbit, or its last energy level. So they are reactive. They are still reactive metals, but they are less reactive than group number 1. So actually going back to the periodic table, so the metals, if you remember, here is our staircase. The metals are found on the left side of the staircase. The first group is the most reactive, and as you move to the right, the groups become less and less reactive. So even though these are all metals, the most reactive is group number 1, and then group number 2 is less reactive, group number 3, group number 4, etc., etc. So the alkaline earth metals are less reactive. They are still reactive, so they're still not found pure in nature, just not as reactive as number 1. So how it gets its name, actually, alkaline means basic. So if you remember from grade 10, the pH scale, pH higher than 7 is then called a basic solution. So the reason why it's called this is because, oh, sorry, my dog is making noise. The reason why it's called an alkaline earth metal is because when these metals react with water, it creates actually a basic solution. Okay, so in general, metallic properties. So there, before we kind of get into this, there are going to be exceptions to these properties we're going to discuss. So these are just more in general. Okay, so in general, metals are good conductors of both heat and electricity, right? So that's why we use metals for electric wires and for pots and pans and different things that we want to heat up. Metals are malleable, so meaning we're able to hammer them and bend them, make them into different shapes, right? So if we're looking at this Tut, I won't say mummy, it's not a mummy, but it's a sarcophagus that the mummy is in. So this is metallic, right? But we're able to bend this shape because of the fact that metals are mostly malleable. Metals are also ductile. So ductile is a property where you can then make it into very, very thin wires. So the fact that, of course, you have a conductor of electricity and we can make them into wires, well, that's like a win-win situation, right? So we have electricity and we are able to, electricity is able to move through them, and it's also able to be made into wires. Metals in general are very strong. Okay, so even though we're able to bend them into different shapes, usually you can't do that at room temperature. So in order to make it bendable, typically you may have to warm it up, right? So generally metals are pretty strong. Like think of like a chunk of iron or steel, right? So you have different metals that are there. And metals have luster. We can say they're lustrous. So meaning in general, most metals are shiny, right? So luster is a property or term, scientific terminology for shininess. Okay, so transition metals. So notice we talked about group 1 and group 2, but we didn't talk about all of those metals in between. So group 1 and group 2, so alkaline metals, alkaline earth metals, and then we have this center block of metals. So they're known as the transition metals. So we kind of just group them together. They have many different properties. Of course, they're all metals. But some of them are actually kind of unique. So a lot of those, remember I mentioned there's going to be exceptions to those properties. So a lot of the exceptions happen to be in this center block. So for example, copper in its pure state is actually very soft. Copper at room temperature can even be bent into different shapes. And it's a very good, of course, conductor of electricity. Most wires that we use are actually made out of copper. Mercury is the only metal that exists at room temperature as a liquid. So metals are all solid at room temperature except mercury. Mercury is the only liquid metal. Okay, so metalloids. So metalloids are the elements that are along the staircase. Okay, but notice there are 2 empty spots. So the element here and the element that is here. So this element is aluminum that's missing from this. So even though aluminum is on the staircase, it is in fact a metal. Over here to the right, we go back here, I believe it is astenine. Yes. So this is also a non-metal. So basically, so here's aluminum, here's astenine. This is a non-metal, this is a metal. However, and you can see them in purplish color here, these are our metalloids. So a metalloid is really an in-between element. So it has some metallic properties and some non-metallic properties. So it's properties of both metals and non-metals. Okay, so for example, metals in general are very strong. Non-metals tend to be brittle. So metalloids are actually kind of in between. So they're a little bit more brittle than a metal, but less brittle than a nonmetal. Some of these metalloids are able to conduct electricity, but not able to conduct heat. So they have kind of a mixture of those properties. Some are shiny and some are dull. So for example, you can have something that can conduct electricity like a metal, but it's dull like a nonmetal. So it's a mishmash here of properties. So here's an example. So silicon. So silicon is a metalloid. It's shiny, which means, hey, this is like a metal, right? But it's brittle, like a nonmetal. And it can conduct electricity, but not heat. So, this is actually the beaming example of what a metalloid is, because it does include really, truly kind of half the properties of each type of element. Okay, and of course we have nonmetals. So nonmetals are on the right-hand side of the periodic table. If we go back here, so our nonmetals are found on the right-hand side. And keep in mind, hydrogen is included in that nonmetal element type. So when we are looking at nonmetals, again, there are going to be exceptions to these rules, but in general, some properties you're going to see. So nonmetals are not great conductors of anything. Actually, they tend to be great insulators, so meaning not conductors, right? Nonmetals tend to be brittle. Instead of being malleable, bendable, if you try to bend a nonmetals, they'll basically break. So for example, carbon is known as graphite when it's in your lead. So when you say pencil lead, we call it lead, but really it's carbon. So if you know that if you try putting enough pressure down on your pencil lead, it tends to snap pretty easily, right? So it's a very brittle substance. Many nonmetals are gases at room temperature, okay, but there are actually nonmetals that exist in all three. So you have gases, one liquid, and solid. So most of them are gases. If we were to go back to our periodic table. So of course our noble gases, we'll talk about them in a sec, are all gases. Fluorine and chlorine are gases, but actually bromine is the only liquid nonmetal. So remember mercury, we talked about mercury over here before. There are two liquids that are found naturally in its elemental state. Mercury is a metal that's a liquid. Bromine is a nonmetal that's a liquid. Okay, but you do have a lot of elements here that are gases, including hydrogen. Okay, so some other nonmetals. So phosphorus is a very reactive nonmetal. Sulfur is very brittle. It's almost like it's easy enough. You can actually, if you were to take this solid block, this chunk, and squeeze it in your hand, it would actually become a powder. Okay, that's how easy it is to actually crush. Just your hand strength is enough. You wouldn't want to do that though, because sulfur is actually very stinky and it's not really great. It can absorb into your skin, so it's not really great to do that. But I'm just kind of explaining the fact that it's softer than metals would be. Now remember we talked about how graphite is very brittle. Funny enough, a diamond is also made up of the same thing. A diamond is also carbon. Now, the reason a diamond is actually the hardest substance on Earth. So this is kind of an exception to the rule. The graphite form of carbon, it follows the nonmetal trend very easily. But diamond is made up of nonmetals, but it's very strong. The reason why is because diamonds are compressed over a long period of time with heat and, of course, pressure from being underground or in a mountain. So with the rock, essentially gravity crushing down on that carbon over time. If you continue in grade 12, you will know why it has a different property from graphite. But just for now, you can just think of it as being just another example of a nonmetal that's kind of an exception to the general rules.